Alright, let's take a look at what this actually looks like in practice. The vector product using the distributive law. So remember this little thing here? We can also use our table if we want to use our table. There. Now we're going to take our two vectors, a, 2i minus 2j plus k, b equals I plus 2j plus 3k, and we're going to use the distributive law to multiply a times b. So, a times b equals 2i minus 2j plus k, bracket, bracket, times I plus 2j plus 3k. So distributive law, this times this, this times this, this times this, this times this, this times this. We're going to have 9 answers altogether. We need to be careful about whether they're positive or negative in each of them. So first we'll do it without reference to this, then we'll look back at this and decide how we're doing this. 2i times I. That's that one. 2i times 2j. That's that one. 2i times 3k. Alright, so there's our first 3. Next we've got negative 2j times I. Times I, then negative 2j times 2j, then negative 2j times 3k. And then our last one, I'm going to have to keep going across here, k times I, do a plus over there, k times I, k times 2j, and k times 3k. Okay, so now that we've got all of our distributive law sorted out, now we need to multiply each one by one, with special consideration to our little diagram here. So let's go through it. 2i times I. A vector times a vector, the vector product of that's just going to be 0. So 2 times 0, 0. Alright, next one. 2i times 2j. That looks like it should be 4. Let's take a look at our table. I to j. I to j, we're working in the clockwise direction, so it's going to be positive. So positive in the clockwise, and it results in a k. So we end up with plus 4k. So I times j makes k. Good. Next one. 2i times 3k. Well, that looks like it should be 2 times 3, which is 6. But if we're going from I to k, we're moving backwards. We're moving in an anti-clockwise direction, which brings us to j, negative j. So it's going to be 6 times negative j, which is going to be negative 6j. Next one. This looks like it should be negative 2 times 1, which is negative 2. But we're moving from j to I, which is going to be a negative k. So it's actually going to be negative 2 times negative k, which is going to be positive 2k. Alright, this next one here. Negative 2j times 2j. We're multiplying j by j, so that's just going to give us 0. Done. Alright. Negative 2j times 3k, that's negative 2 times 3, that should be negative 6. We're moving from j to k, which is in the positive direction, so that's going to give us positive I. Negative 6 times positive I, negative 6i. That's that one done. Now k times I, that's 1 times 1 is 1. K times I in the positive direction, that's going to give us positive j, so it's just plus j. K times 2j, that's going to be 2 times 1, or 1 times 2, which is 2. K times j, we're moving in the negative direction, so that's going to give us negative I. Alright, so it's 2 times negative I, negative 2i. One more. K times 3k. Oh, great. K times k. That's going to give us 0. 3 times 0. 0. So, our final answer here is 4k plus 2k. That's 6k. Negative 6j plus j, negative 5j. I've just done things out of order here, that's fine. Where's our i's? Negative 6i, negative 2i, negative 8i. Plus. Hopefully you noticed my mistake here. Negative 8i minus 5j plus 6k. Let's get I, j, k in the right order. Let's go look at GeoGebra, see what this looks like. So we had two vectors, u and v, so 2, negative 2, 1, v, 1, 2, 3. If we do the vector product of those, what we end up with is a vector perpendicular to both of those. You can see, hopefully you can see it's sort of making a 90-degree angle with those two vectors, and it's negative 8, negative 5, 6. So just a reminder of back where we were. But here's our process. It's the distributive law of finding the vector product. Don't worry, there is an easier way.